Suzanne Hambrusch and Rich Schlesinger. Suzanne is a professor of computer science at Purdue University, former department chair. She's going to tell you about the stuff she does, but a lot of what she's done in education. Currently, she's got a couple of NSF projects, the CCANT project and the CS4 EDU project. Has done wonderful things in education at Purdue. And Rich is at Kennesaw State University. I'm going to use my little cheat sheet here. You can, of course, read the bios, but I just want to highlight them. I think one of the big things is he's done Cybertech, the curriculum director, and also really one of the people who was one of the heavy lifters in terms of developing Georgia's certification standard for CS teachers. So without further ado, I'll turn it over to them.
Okay, so we'll split it up. That I'll have about 20 minutes that I'll talk. Then Rich has about 20 minutes. They're very complimentary talks. And then we leave some time for questions for the audience. And I hope you have some. So both of those talks are about teaching endorsement. And if you went to Jane Cuny's talk and Chris Stevenson's talk, sort of addressed the issue of how we train the teachers. And in both of us, Rich started a few years back, and we have done this within the last year at Purdue, really saying, well, why don't we have, I'm in a college of science at Purdue, and every other department in science has actually an education major. So you can be a chemistry education major, a physics education major. And in computer science, we have nothing. And this sort of came up with saying, well, why don't we talk to the education people, which we also have never done in computer science. And they were surprisingly nice people. They were very interested and they were very knowledgeable. They actually knew more about computer science and technology also, and they understood that these were two separate things, and that's how this project started. And so the CS4 EDU, this is an effort between computer science and the whole College of Education. I still don't quite understand all their departments and their structure. It doesn't matter. It's one big thing for me. And there's curriculum and instruction, educational studies, and educational psychology, and all of these go on. And so we're a couple of faculty in computer science, and we'd really feel that we've seen the enrollment go down from 1,000 undergrads to 400 in probably 3 years, 4 years, and you'd realize, there's something we're doing wrong. I mean, these kids don't know what this field is all about, and the education faculty who understand that there's a role of computer science and not just computer technology in teacher education. And this is the website of the project that we then actually wrote a proposal, got funded, and we have really been working on this now for 1 year. Now, teaching, how many of you are teachers? So, okay, just 3, okay. But you all know something about computer science in high schools, even if you're not a teacher. In Indiana, it used to be in the math department until maybe, Mindy knows that, maybe 7?
It's like 10, probably.
Yeah, so, and then it switched into business, and it's sort of a change that nobody really knew it happened, and nobody really knew what the impact was, but the impact's really enormous. So it is in the business school, and there is no certification required, and there are no standards that have to be met except for the AP course. And there are some schools that have nothing. There are some schools that have actually very good computer science courses, and there are a few that have only the AP course, and everything else is random. And that's very typical for what goes on in other states. So what we wanted to do, actually, this project has a couple of goals, and the first one was really to create a licensure or an endorsement in computer science education, following the ISTE guidelines. And that would be, we would create this, and this would be a Purdue-only endorsement. I think this is, yeah, so this would be a Purdue-only license, so a secondary teacher, probably in math most likely, but could also be chemistry or physics, would then get an endorsement which says, you have fulfilled the computer science education endorsement. we've started this, and our semester ends too soon. We didn't complete it last year, but we'll finish it in the fall. Our second goal is to actually have, and that's what Jan Cuny said, to have CS count as a math requirement both for admission and in the high schools. And so what happens, you really need to look wherever you are. You need to look at the status, because we were just blown away. Purdue requires 4 years of math for admissions, and not only is AP Stat allowed, but there is also things allowed that the teacher never heard of. All kind of math courses are allowed, and we said, what are these courses? Then when they're there, why isn't the AP course in CS on there? And we've actually gone to the admissions, and this may actually happen. More difficult one is the Indiana high schools require 4 years of math, and we've gone to the Department of Education, and they were actually very savvy. They turned around and said, they said, no, this is not really a serious problem, but first what you should do is you need to count it for admission. So they send us back to admission, and and once we have admission, we will go back to them. So these are the two things that are a goal for us, and we've been very persistent. Steve Cooper, many of you know, he was at Purdue last year, and he helped us with this, and so that has gone quite well. And what we also then like is really have a set of standards which everybody smiled and was very polite. And Rich will talk about this. So here is our, when we created this endorsement, one of the things we did is we said, how do students at Purdue end up to be teachers? They don't, at Purdue, it's a big state school. Students have to declare a major when they come in. And that means many of them switch, and they carry this, that many courses don't transfer, so that they carry courses along that they aren't sure what to do with. Really, we have some people that start as education majors. We have some science majors, which may be science education majors. Those students will take some computing courses. They will actually take some of the courses that are already relevant to teach computer science. There are also then transfers from engineering or from technology, which also come in with some requirements that count. And so we've made this picture which sort of says how things, these three different groups of students, they would enter what you have up here on the right. These are the sort of the required components. They would enter them at different levels, and then they would come and pick up education courses. And one of the things I've just mentioned here, what we did last year in required education courses, we've actually put in a week of just lectures on computational thinking. And we had education faculty who really went in and just talked about what is computational thinking, what are examples of when you do it in life, talked about some of the CS for fun activities. And there were 2 sections, and the elementary school teachers they loved it. They actually got much more involved compared to the secondary teachers. So these, again, you have to sort of create students' interests, and so this was one of them. The other thing that we're working on that I'll talk about here is we're developing a computer science methods course, and we're offering it next year. So this is our big outline of what we're going to do. It's a little bit like a mini minor, and what I show here is that for many of these requirements, we allow courses from different departments to count, and I think this is really important. We want them to have programming experience in at least 2 languages, and with respect to C, there are 4 courses that we would consider satisfying this. There are 3 discrete math-like courses. There are 2 data structure courses, and so the only place where we did not give any flexibility was this introductory Java course, because I think that's one where, as it is now, we want people to really go through the same experience, and we do have some control over the course that it really prepares them to teach the AP course. There's a little bit of flexibility in this. Last year we taught a contemporary issues on computing course, which may disappear if one of our courses gets sort of adapted to the CS AP principles course that we heard about earlier. So there is a little bit of shift, but it does have 4 courses in computers in computing that they would have to fulfill. So that's the computer science component of that endorsement, and then the education component is these students will take all their education courses because they'll have to have a primary major. And so the only thing they'd really have to do is take this methods course, which is a new course. And then our goal is when they have the teaching practicum that they can actually, if they do it in chemistry, they can do chemistry and CS at the same time. And we have contacts with schools where we know that this could actually work. And the methods course, that is, we looked at the methods course in chemistry and physics and math, and then you see, well, what should computer science look like? And from math and from many of them, we picked up that you want some micro-teaching in the class. It means the students teach to each other. We probably tape them, but that's in the class among themselves, among their peers. We'll send them into some of the existing courses at Purdue where we send them into the labs and the recitations to actually teach. So there is teaching in an environment where they're with college students that start maybe in a course that they have taken, and then the teaching practicum would be the one where we send them out to the school. And the methods course is here's sort of the details of it. And it's here is what so how we actually started it. We sort of looked at the existing courses. We then had a workshop for teachers, and we had about 10 high school teachers that teach real computer science, and we brought them in and we asked them, what do you do? What do you wish you would have known? What would you actually do if you had to tell somebody what it's like to teach computer science? And so based on this, we've made a couple of sort of units. The toughest one, the introduction to computer science, is I think this would be something like 2 weeks of it. Really give an overview of the field and what it's and what it all involves, what it involves to teach it, what is it programming versus problem solving versus computational thinking. There would be students that some of them would have taken another methods course, some wouldn't. So there will be some time on the pedagogical approaches to teaching and teaching in CS, which is a lot of the CS teachers who actually teach math and CS would say that lesson planning for CS is very different from math. So what is it that they feel a math major would have to know? How to manage a lab. So those would be a part of it. And then we went through tough topics, and those are sort of the ones that came up. As I'm saying, well, these are tough topics. We'd like somebody teaching it has to understand that they are tough, and how do you actually teach them? What are different ways of teaching them? And we'd really like the kinesthetic activities and role playing. A lot of teachers that we've talked to are actually doing it. They do have their props, and we have a wonderful video of Rob having his object-oriented kinesthetic role play, and so, but I mean, actually starting from from data structures and from variables and from all these things, just really have them act out and visualize. I think is really, really important. And the more experienced teachers all realize that you have to do that. We taped some of the teachers when we interviewed them on how they do things, and so those material would go into the methods course. I think visualization is important, both visualizing execution, output, data, algorithms, how they run in all levels, and we have some people working on it that are actually working in visualization. I think there'll be probably a 2 weeks talking about the AP Java course, the AP Principal course, how to run it, how to actually prepare students. I think this is really important. Teachers really say, we really have to know how this works. And basically, then, throughout the course, there will be sort of nuts and bolts and essentials, designing and grading exams. Our goal is to actually collect projects that students have done and give them to the teachers to grade, so they actually grade something, and that they see not just how to grade, how does it work or does it not work, but how do you really grade and what to look for. Everybody will tell you, dealing with the IT staff, you have to be prepared when you start that this is a tough one. It goes under the tough topics, okay? And actually, each one sort of finds a different way of dealing with it. There is no uniform formula saying this is how you do it. The professional organizations, the resources standards, and those nuts and bolts things sort of get sprinkled throughout the course. So how did we come up with those? We interviewed high school teachers. We taped them. We have 2 teachers working with us this summer as a red supplement. We had a workshop where we had a range of teachers. We looked at the existing courses, and we talked to various education researchers, CS education researchers. So that's how we put this course together. We then realized that this is if the course really works as we planned, it'd be great to have our grad students take it before they become TAs in these 100 and 200 level courses, especially if they come from foreign countries where they have no clue what the background of these kids is like, and maybe even the faculty we hire. You know, we don't really ask, can you teach? We ask, can you speak? Otherwise, we don't hire you. But it is really, I think there's a lot of things in there that we plan to cover and make available for the students, where you say, wow, I wish I had known that. So that could be a nice side a benefit. Overall, what we're interested here is really from talking to anybody, saying, well, you know, what other things should we add? What activities do we have? What works in labs? What are some sort of hands-on activities? What are resources? How do you the practicing grading is just, I think it's really important to see, here is a problem, here are 5 assignments, how do you grade them? And what do you wish you would have known? That's, yeah.
So I know a science program that has a university that has a master's of science for teachers, and part of that program is to put the teachers in a research lab for 1 semester, so they get that hands-on understanding of what research in the field is like. Have you considered having a practicum for computer science teachers in industry or another setting where they see
the actual real world?
Yeah.
No, okay. So in a research lab with the amount of CS they know, I would assume that it would not be a good match at a research lab let's say at Purdue, because the corresponding undergraduates with that level of courses, nobody would take in a research lab. Now, we do have companies that after they've taken the courses that I list here, would certainly give somebody an internship. And so if you go back to the beginning, we have one course saying you have to fulfill something, some other computing-related activity. And we thought about, if you know what EPICS is, these community services projects, that would be one of them that would definitely count. And I think an internship somewhere would also fulfill that. So there's some other activity you do, computing-related, that could be a course or something. And it could fit in, but that's actually a nice, a good idea. Not many. I mean, there are some companies who, after sort of a minor in CS, will give a student a summer job. Yeah. Mm-hmm. So.
It isn't to take on their own research projects.
Yeah, it's just so that they see. Yes. And I think for in this environment, is what the workforce looks like is actually, I think, is even more valuable than the research lab. Yeah, that's a nice idea. And so here are the people that we'll work with. You know, Stephen Cooper, he just left, and we have 3 people from education. And actually, Amanya Duff, I think he was a mechanical engineer. So as an undergraduate, so you see these people end up in education fields, various paths, and I think we just need to realize in computer science that this can really work for us. Now, what we would have to then do after we have this in place, if we'd the Purdue-only endorsement it's not a big deal. I mean, the education people, one of them is an associate dean. I don't think we'll have any. As long as we do all the paperwork and do all that, we'll be fine. What would come afterwards, Rich is going to tell you, because that's much messier. Okay? So, let's see, I got... Okay.
And the microphone.
Yes. You have a pocket?
Yeah. Okay. At Kennesaw State University in Georgia, we also created a CS teaching endorsement. The difference is we've also gone through all of the approvals that are required. The actual content of our endorsement is really very similar to what Suzanne has done. So I'm going to talk about all the other stuff rather than the content of the program itself. Okay. Our College of Science and Math produces a large number of math and science teachers in the state of Georgia, and our dean considered CS to just be a natural extension of what we were doing there. Now, this actually took 4 years for us to get all of this, and I'll go through the details. In 2005, we received an NSF grant to basically encourage underrepresented minorities to pursue STEM careers. And as part of that, we went to high schools in the area to get them to offer CS courses. Okay? And we provided teacher training workshops. We had a master teacher create lesson plans. We had grad students come to the high schools to work with the students. All those things to support them. But, as in many states, including Indiana, CS is part of business education. And what we found was the typical business education teacher was well qualified to teach Word and Excel, but not CS. Okay. Meanwhile, at the same time, Georgia Tech was offering workshops for people who are real CS teachers. Okay. And they found out that many really high qualified teachers were leaving the field because there's just no recognition of CS as a teaching field. So we jointly went to the state licensing agency, which is called the Professional Standards Commission, or PSC. And we got them to agree to create a CS teacher's certification. Okay, just like physics, a physics teaching certification. So a committee was formed that consisted of current AP computer science teachers, representatives from colleges of education all over the state, and the people from the KSU and Georgia Tech computer science departments. And we met for about a year, once a month. We used what is now the NCATE CS teacher preparation guidelines to create a Georgia-specific standard. It's really the same thing, just some wordsmithing on things. That was the easy part. Now we had to understand, how does the PSC actually do things? Okay, what are all the rules and whatnot? Okay. When we started, the committee had hoped to create a full teacher preparation program, just like math education. But the PSC insisted that it needed to be an endorsement because they had this very important issue, that most schools would not hire someone who could teach only computer science. Okay, you've got to really be in a metropolitan area with a lot of students to justify that. Mm-hmm. So they instead made it a separate endorsement. Okay, then the question came up of what grades would the endorsement be for? Well, Georgia had just created a 3-course high school sequence based on the ACM CSTA K through 12 recommendation. So the committee said, okay, this endorsement applies to high school to teach those courses. We were very happy when the PSC later came back and said, no, the endorsement can apply to all grades. So that's going to allow someone who gets the endorsement to work in a middle school, or we even have someone who's working in an elementary school expressing interest in getting the endorsement. All right. We wanted the endorsement to be mandatory. In order to teach computer science, you had to get the endorsement. And we proposed a transition period and grandfathering of current teachers and all those sorts of things to have that happen. But the PSC asked, okay, who's going to offer teacher preparation programs so that we can prepare the teachers? There are 35 institutions in the university system of Georgia, going all the way from Georgia Tech as an R1 institution down to lower level colleges. And KSU was the only one that committed to actually offering the endorsement. Since we basically cover the northwest quadrant of the state, that would mean someone in Savannah or down way south in Valdosta really wouldn't have access to the program, at least until we create an online version of it. So based on that, the PSC said, make it optional. Okay? And that, in turn, is coming back to haunt us, and I'll talk about that in a bit. Okay, now, usually, if a teacher wants to, say a math teacher wants to also become a chemistry teacher, they just need to take the state-approved test to show that they're qualified to teach chemistry. We wanted the same flexibility, but the PSC said it was going to cost them $1 million to create that test, and they didn't have the money to do it. All right, so that means that if an existing teacher wants to add a CS endorsement to their teaching certificate, they have to come and enroll in our program. Okay, so after meeting for almost a year, we finished what we needed to do, and then the PSC formally approved the endorsement in late 2007. Unfortunately, it's all legalese. If you don't have a copy of what the committee actually wrote to compare against this legal document, you have no idea what is being asked. People over in the education college who deal with this stuff all the time looked at it and said, what are they saying here? So that's unfortunate. All right. Once we had the state certification in place, we then started to design our own endorsement. Okay? And as Suzanne did, we used existing CS content courses, and we designed a new CS teaching methods course, which is very similar to what she talked about. Unfortunately, at the same time, the CS department was doing a major redesign of its entire curriculum. And so since we were depending on the existing CS courses, we had to wait until that redesign was completed before we could proceed. All right. So then in summer of 2008, we got the department and the College of Science and Math to approve, curriculum committees to approve it. And now we needed to get the College of Education to approve it. And this required us to do things we had never even seen before. We had to document how the program met NCATE requirements. Okay, NCATE is the national organization that certifies colleges of education. All right. So we got that done, and then in the fall of 2008, we finally finished the university approvals. Now we had to get state approval for our particular program. And this required a massive documentation effort. Instead of just generally how we were going to meet the guidelines from NCATE, we had to show exactly how we were going to assess the students were able to teach the material. We even had to write tests we were going to give to the students. Okay? And then in March of 2009, a formal review team came on site. And finally, in July of 2009, the PSC gave formal approval for us to offer a state-approved CS teacher preparation program. So at that point, we started saying, okay, well, great, we got the program, we need students to enroll in it. All right? Well, all through the process of creating this program, a lot of people had said, hey, this is great, this is fabulous, you guys are doing this. So we initially had a, if we build it, they will come attitude. Didn't happen, okay? So now what we're doing is we have created a coordinated effort with the math department to basically focus on the math ed students, okay? They are required to take our intro programming course, okay? So we basically look at the students in our intro programming course who are math ed students and say, okay, the ones who are doing well in this course would probably be motivated to teach CS in addition to math. So we go and approach them, and we've gotten a good response. But, as I said, it's an endorsement, so it increases the number of courses that a student needs to take in order to graduate. So that's a demotivating factor. All right. And as I mentioned, the PSC requirements that you can't just take a test to add this as a field discourages existing teachers from getting this certification because they have to spend time and money to enroll in the program at Kennesaw State, and currently there's no additional salary that they get for adding the certification. Now, before the state went into its current budget crisis, the legislature actually passed a bill to give an increased salary to math and science people who become math and science teachers. Okay, and we were in the process of getting computer science added to that list. Okay, so hopefully if the budget crisis ever gets fixed, we can start paying CS teachers more money. Okay, the thing that has been mentioned a couple times about having AP computer science accepted as a math or science program. Georgia recently changed its high school curriculum to require 4 years of math and science, and we have gotten the state to accept AP computer science as the 4th science. Okay, and in summary, it's a long process, and it needs strong support at a high level. The dean of our college was strongly in support of this from the very beginning. And that was one of the major things that helped. And then as far as people actually working on creating the endorsement, well, it's very similar to a minor in content and hours. But all of the but it's not like them because of all the additional NCATE and state approval procedures that you have to go through. And you clearly need someone to help you navigate that maze of approval procedures. Close working relationship with the College of Education is an absolute necessity. Otherwise, this sort of getting this to happen will just totally flounder. Okay, and okay, just a few acknowledgments. Okay, and that's basically what we went through. Are there questions? Yeah.
The test in Georgia, is that the praxis test through ETS?
Okay, it used to be the praxis, but Georgia now has had some conflict with ETS, and so they have created their own Georgia tests, which is probably why they said it would take $1 million to create a test.
Okay.
Now, if your state is using the praxis exams, you're a lot better off.
Well, there is no praxis exam for computer science.
Right, but we could conceivably, that's something that we could conceivably work with ETS to establish, okay, But you know, it's one of those chicken and egg things that they're not going to want to create the test unless there are a lot of states interested in having people take the test.
Right. BTS has said, I think it's 1.5 million they want to create the test.
Okay. So, all right, same ballpark.
Yeah.
Yeah.
Have you guys looked at marketing at all to in-service teachers as well as the pre-service teachers?
Well, as I said, right now we have been marketing to the in-service teachers, but because there's no incentive for them to do it. They have to spend their own money to enroll in the program at KSU, spend the time, and then they get no salary benefit. Now, once we're able to get the salary benefit in place, just like for science and math teachers, that may change.
So it's come up for us, you know, when we went to the Department of Education, it comes up, let me go and say this to him. It's always a question that they ask, and so I think even for us, you have to think about a model to deal with the in-service teacher.
Right.
I mean, it's just, you can't just create this and then
Right.
and just say, well, they'll die out eventually. That just doesn't work, okay?
No. And as I said, from the very beginning, back when I was on the state committee, we wanted a way to grandfather in existing qualified teachers and provide a transition, and just didn't happen.
And you know, doing some online learning of some courses, once you have the courses in place, just think of something that you can do. I don't think it's impossible, but it takes some effort.
Yeah. You were going to have another question?
Do you know if in Georgia, do teachers get a salary bonus for being nationally certified?
They used to until the current budget, until the legislature hit them this year.
Have you guys thought to work together to work on reciprocity? So if teachers do actually go through either program, they would be certified in both states?
Well, they're not all that different. I think from the content, and I think what you have, you then also have electives where you allow them to take possibly some of the technology-related
Right.
courses, which we would in the elective would allow one, and you guys allow two. So
yeah, I mean, as far as Kennesaw State and Purdue, it's probably not an issue.
Yeah.
The issue is going to be with the state agencies.
And I think overall, the CS teachers in you know, statewide, and Minnie knows that too, in Indiana, it's been a really tough year for teachers.
Mm-hmm.
And one of the CS teachers who's been who teaches math and CS is a really, really good CS teacher, with a lot of experience in teaching AP courses and other courses. She's not even going to teach CS next year. She teaches the CS AP course as an overload. Because of the budget cuts that the state had let a lot of teachers go, the corporation has, and so it's just but again, at the same time, you can't just, it doesn't make it, things will change and you still have to move forward.
Right. As far, oh yeah, I'm sorry, go ahead.
Well, I was going to ask, you seem to focus on the mathematics teachers, which is a kind of natural
Right.
thing, although it's a business certification, and
Well,
where I am, some of the best CS teachers are likely to come from more quantitatively oriented parts of the business program. In fact, that's where the former software people seem
Right.
to wind up is in business.
yeah, the reason we're focusing on the math students is, again, these are I'm talking about the typical undergraduate education major is they already take the beginning programming course, and we've established a very good working relationship with the math department. We're in the process of establishing that same kind of relationship with the other science education departments.
But even though, I mean, I know in South Carolina, the AP endorsement can appear on top of 14 certifications.
Right.
General business is not in that, but
Right.
accounting is, and some other ones.
Right.
So, and there are teachers that I have
Right.
worked with
And
who do
and some of the some of the best CS teachers that I work with actually came from industry. Okay. So, I mean, I'm not discounting that, but we had to create a program to try and target the typical undergraduate student.
So the answer for us is that Purdue does not have education in business. That's at Ball State. And so for us, there is no education link at Purdue. And I think we have talked to people at IU, and we do have contacts at Ball State. And so our goal is actually, once we have this in place, to have these other places have this endorsement too.
Right.
We also then looked, for us, we have the math education is 120 students total, versus the physics. I think a physics teacher could make a great CS teacher, right? But we have about 10.
Right.
And the chemistry is about 10, and the biology is about 40. So just looking at
same
this,
type of numbers.
Same type of numbers. So I think our yield is really the best in math. Now, if we looked at overall where the people that get education degrees, secondary education teachers, what are their fields? You know which one's the max of all at Purdue? It's the social science student, because they want to be a football coach or some athletic coach. And so it's like, maybe we should market this more to really go into liberal arts. It is not said that these people couldn't do it.
Yeah. Well, I can give you a personal example of that. My wife is a teacher, and she was interviewing to teach at a high school, okay, and the principal was interested in her only because she could also coach volleyball. So there is some of that.
Originally.
Yeah. So I think your point is we really need to think in a very broad sense, and so when we go and into these required education classes, that's really what you'll have to hit, because there may be students that have never thought about it.
And also the in-service teachers.
Yes.
Because there are people who come from industry.
Right, right. And like I said, we very much wanted to get the in-service teachers certified, but there's no rational path at the moment.
Chris?
I just have a quick comment and a question. I was just in Turkey, and they've launched this whole new program where the students who want to become computer science teachers start training to become computer science teachers in early high school. They're recruiting way down at the level of high school to get teachers for the computer science and engineering field. So that's just an interesting comment about different perspectives about what's important nationally.
Right.
But I mean, I know you, Suzanne, and you're an incredible scholar, and you do great work in lots of fields. And Rick, I know you're incredibly busy. Why, this is almost like no good deed goes unpunished when you start working in this area. Why personally did you choose to put all of your incredible work into this?
Well, so I wouldn't have. So I was head for 5 years, and I realized how bad things can get. And as I went on being head, things got worse and worse. And I went from about 15% females to 7, and I sort of felt like, man, what did I do? And and you realize that there are just a lot of things wrong. And I think without this experience, I probably wouldn't have put the energy in it. The other thing was that I worked with people who are very passionate, and we couldn't do this without the education people and without actually a whole bunch of faculty who haven't done anything in education really caring about it. And so I think we have a fairly big group that really drives this. When we started talking to the Department of Education and Admissions, we are all very competitive. It became something that we want to do because we know we can do it. And we would use Georgia and Texas as the states where they have successfully changed the role of CS. We're only talking CSAP. I mean, we're not talking about any sort of random course. And I think we all became very competitive to convince them.
Okay.
And
in my case, I was the curriculum director on the NSF grant that we had 5 years ago. Okay, and I saw firsthand the problems that we were having in the high schools, and I said, there's got to be something that can be done about this. Little did I recognize it was going to take 4 years to get the whole thing in place, but I said, we got to fix this, and that's what got me started.
And I actually think it's 10 years ago, if you'd gone to computer science departments and computer science faculty, people wouldn't have cared. I actually think you go now, you do find people who care. You actually find grad students who really care, and we have a significant number of grad students who want to go into teaching positions. That didn't happen You know,
Right.
in 10, 15 years ago, where if it wasn't R1, it wasn't
Right.
good enough.
And yeah, and I got a lot of encouragement from my department and my dean because they saw declining enrollments in computer science, and they said, okay, we need to get do the thing to get students there out of high school. And that NSF grant that we had 5 years ago was intended to do that, and it didn't really do all that it should have because we recognized we didn't have the teachers in the high schools. So the dean said, okay, we need to take a step back and fix that problem.
Yeah.
Is there a role to play for faculty who are at private colleges that don't have graduate programs and don't have connection directly to educational schools? You know, like what can we do to sort of help these kinds of efforts go forward?
Okay.
What kinds of connections do
Yeah.
you suggest we start to build?
So I think one message is that for the students you actually go through your as undergraduates, that they actually get the message that there is actually a path in computer science that is a teaching related in a high school. I think many there's just no awareness of that, and I think that is just something that you know, I'm not sure, even if you don't have an education major at Union College, you just still say, you know, whatever you do, that is still a possibility for you. I think that's one thing. You know, we don't really have research in computer science in the computer science department. I have no shortage of highly qualified grad students to spend a year working with me because they get experience that they said that will make me, if I want to apply for a job in a small liberal arts school, I will look so much better compared to everybody else who only can do research. And so I have very qualified grad students spending a year doing some on the methods course or on some other course development. And so I think that's also, you know, for a small college to actually say, well, you know, there are people out there that are more versatile than just being the research machines. Can you think of something else she can do? She's good.
I have students who are teaching high school now.
Yeah, yeah. So.
Other questions?
Okay.
Okay, thank you.
Definitely thank our speakers.